Hey guys, I wanted to get with you and share with you something that I've been working on for a while. A little bit of a discovery, kind of an accuracy hack for making 300 blackout brass, forming 300 blackout brass, and resizing 300 blackout brass. And in this video, the primary thing is I want to cover the use of the Lee collet die. This is fairly newly available, and we'll be using it in conjunction with the full-length sizing die, as opposed to instead of, which is how this was originally designed. So it's a little bit, outside the norm there. And since we're talking about brass anyway, specifically, we'll also cover shoulder setback and some things you could do to improve accuracy in that regard. I'll talk a little bit about what makes a good piece of brass. We'll cover what the Lee collet die does do and how it works. I'll show you a setup and operation. We'll talk about what's going on here, what's different between these two, and why they don't necessarily interfere with each other. One doesn't keep you from doing the other, in my opinion. So that's what we'll cover in this video. So stick with me and I'll try to make it worth your time. So let's briefly cover some brass basics. What makes a good piece of brass? And this is a 7.5 by 55 Swiss. I'm just using it for illustration. And for the bench rest guys, I know you guys have a lot of stuff that you're very detail oriented, so cut me some slack if you see something I miss, or put it in the comments and help educate me and everybody else if I'm missing something here. But so basically what we want is we want all our brass to be the same. That's why people sort head strands with the same basic capacity. We want the head to be square to the center line of the case. That's why I'm using this square here just for illustration. We want the neck to be square and concentric. We would like this case to fit as close as possible into the chamber that we're firing it in and still be functional. We want the shoulder to be up, as close so that when the bolt comes home and closes, this case works like a wedge and fits very snugly in the chamber so that we don't have any misalignment or the capacity for misalignment, and hopefully our case is straight so it isn't misaligned when it is locked in place. Oh, we also want the neck to be even. We want our neck tension to be equal all the way around. We want our neck wall thickness to be consistent all the way around, so there's no pressure points. And we just want that bullet to be able to slide out of there with the most consistency possible and stay straight to the center line of the bore. So when this bullet comes out of there, we want it to engage the rifling and swage itself into the rifling and keep its tip perfectly centered in the bore. And if it does that, if we get that release in that perfect one, it's going to come out the center of the bore. It's going to come out the bore as a perfect spiral with the tip just right where you want it to be. Now, if we end up with a little bit of a concentric problem, and then once the bullet swages into the rifling, if the tip's off center, it's likely going to stay like that and just kind of wallow along down the center of the barrel. And it's not going to be nearly as accurate as if it was in the center line. So think a perfect spiral football versus a lame duck football. Probably a good way to visualize it. So when we are done, if we've done our part and our tools have helped us out, we should get a case that has a bullet seated that has very little run out in it. And like I said, that's really what we want from our case to give us an accurate shot. See, this looks pretty good. This is a homemade Lake City piece of brass. Okay, so let's talk about the collet die. So in case, I don't know if you have the Modern Reloading 2nd edition, this is the die that's featured in a cutaway on the front. Okay, so here's the collet. You can see the cutaway. It comes up in here. It's pushed by the shell holder up into there, and you see this taper here. It squeezes just on the neck. It's the only part it touches. If the die's set up right, the only thing that's going to get addressed is the neck, and it squeezes it on this mandrel stem right here. So let me just show you this a little bit. This is the collet here. Try to make sure I keep it as focused as I can. So you got these slits here, and that's what gives it the ability to flex under pressure and close. And then you have this taper bit here, and then your perfect mandrel. Incidentally, these mandrels are available from Lee in different diameters. So this one I think is a 305 diameter, and if you're using cast bullets, you can buy different ones from Lee. They're not very expensive, and if you need a little bit of an oversized neck for what you're doing there, a little bit of a larger diameter, that's easily addressed. So this goes together like this. Case is up in here. You see how the case is in there. Fits perfectly around that mandrel. And then the shell holder comes up. It's not really pushing on the case. It's pushing, once you make contact, if you're set up right, you're pushing on the collet only. And that tremendous force that you're able to generate, it's focused right here, and it really puts a lot of force on that neck, right on that mandrel. What else? So anyway, you can see that it doesn't do anything. It doesn't affect resizing. It doesn't push the shoulder back. It doesn't do any of that stuff. Those are all things that this die does. But this die doesn't, with the exception of the expander ball, it doesn't really treat the neck with that much specificity. Did I say that right? Okay, so that kind of covers that. Now we talk a little bit about how this die is intended, how Lee intends it, and then we'll deviate to how I'm using it in an unconventional way. So this die is intended, because it only addresses the neck, it's intended for fireform brass. So the idea behind fireform brass is you take this cartridge, this cartridge that hasn't been fired yet, you take it out, you fire it in the exact rifle that you want to use it in. In this case, in this example, we're talking about bolt action. Once it fires in that case, the case becomes blow molded, basically, to the chamber. So the shoulder pushes out to whatever's available, space is available, the sidewalls push out, and now it is the best piece of brass possible for that chamber, because it's custom made for it. And all we're going to do with this, we're going to come back and we're just going to reset the neck tension on it and square it up a little bit. That's the only thing we're going to do. And that becomes a custom piece of brass for that chamber. Now, it's only recommended for bolt rifles. The reason being is because you can insert this, you can push the bolt closed, and you have a camming action that, with some leverage, that you can close that bolt. And that does a great job of centering up the case so that your bullet, once again, is lined up to the center line of the bore. So with an AR, it's a little bit different, because it's obviously it's semi-automatic, and we have some things we got to do. We got to come out of the magazine, we got to come up, reconcile the angle into the chamber, and then we have to go home using spring tension and rotate the bolt into battery using a cam. We're not doing it with our hand. It's all spring tension, unless we're using the forward assist, but we really don't want to have to do that. So we need a little bit of sizing there, full length sizing, so that we have a little bit of tolerance, so that we have reliability. So they do not intend this for an auto-loading firearm. So here's the part where, this is the point that I come into. Since these two things do not address the same thing, my theory was, would it be helpful to add this to this function? And so in a fireform case, or I'm sorry, in a fresh case where you just made it, we've formed a new neck out of what used to be the sidewall of the case, and all we're doing with this is we come back and add this as a second treatment, and we come back and we fix up that neck a little bit more. And I've actually talked to Lee about this die, and there's a tremendous amount of force you're able to apply to it, enough force that you can actually flow the brass. So if your neck is somewhat inconsistent, maybe your neck wall thickness is a little fat on one side or whatever, or in some cases when you trim the brass down, you get a little bit of a catch there, a little wide spot there. And this die will actually I think of it like an iron. So it's sort of just whatever's wrong with the neck, it sort of irons it out. It'll move brass around a little bit. It'll give you more of a consistent neck tension for your bullet. So that's what I do. Fulling size to form the brass, trim it, and then add this step, a single step, to address the neck and make the neck a little more consistent. Okay, so let's talk about accuracy and accuracy potential. Now, the way I look at this and using this as an additional step is however good your brass is, if your brass is perfect and you use this step, you're not going to get anything out of it. But if you have inconsistencies in your brass caused by forming it, or maybe, I think of this mostly for homemade brass, but you might find an application for it on other brass as well. I'm putting this out here for you to experiment with, and if you're interested, and see if you see any value to it. So here's a couple targets. I didn't really plan on this. I've probably done this 11 times or so. I didn't really plan on making a video at first, so I didn't capture all of it. Some of it was, I made the test rounds and I didn't know if it'd do anything, and I didn't save them. I didn't save the targets. I think I have some digitals. If I have them, I'll overlay them in this section there just to show you. But they're not great shots, and but there's enough that you can see that there's a difference. So this was 18.2 grains at H110, 125 grain TNT bullet. This is some shot with a collet die, and this is shot without a collet die. Exact same, brand new brass, just made, and I just added one extra step. And every time I had about a 50% reduction in group size. I didn't measure it, but you can, it's pretty visible. There's a difference there. I'll try to find some other pictures I may have taken. Incidentally, if I forget, I started a thread over on 300blacktalk.com, and I'll put, as always, I'll put everything in the bottom down there, links to it. You can go look at that thread. I shared other pictures over there, and other folks have shared pictures there too. You can see if it's something that you want to, think about or look into further. So, like I said, the better your brass is starting, the less this is probably going to do for you. So I'll make that clear. So everybody is going to get a different result out of this because of that reason. All right, so let's talk a little bit about setup here. So basically, the setup is pretty straightforward. Just follow the pamphlet that you get with it. But it's come down to the stop, and then establish the stop, and then adjust a turn and a half after that, after you make contact. So they do say if you own one of the toggle over or cam over presses, you want to be careful of those. So you want to go an extra 2 turns of what they say. I personally, what I've seen, I might even go 3 or 4 turns because it really doesn't matter. You're just coming down, you're just making contact there. Now with the cam over presses, here's the word of caution. You have the Redding, I believe it is. Big Boss, great press, well designed, awesome. But the problem is it's maybe too good for this die. So because it can cam over, as you bring the handle down on the Redding, it's more significant. But you could be putting the same 25 pounds of force, but as you get closer to the levers get closer to the fulcrum here, your advantage or leverage gets much higher. So the force you're putting near the top of the stroke is not the same as this when you're getting to the bottom of the stroke, even though it may feel the same. When you get to the bottom of the stroke and you're camming over, you have penny crushing force, which this die will not take. This die has, the cap is aluminum, machined aluminum. And we've had guys, one of the guys on 300 Black Talk, he actually stripped it out and because he had too much force there. Now I can tell you that if you get to the point where you are blowing the collet right up through and stripping the threads out, you had way too much force for what we're trying to do here. In fact, you probably made the case worthless. So that said, just keep an eye on that. Now, again, you have the ability to flow brass with this die if you put enough pressure on it. So there have been people who reported seeing lines, the 4 lines from the collet on their brass. And that means that you're literally flowing the brass that was in the neck into the groove. If you see that, stop doing that. That's too much pressure, and you're getting ready to blow your die apart. So just be aware of that. The camo represses you got to go slow with because they really put out a lot of force. In this case, we're using the Lee Classic. So what I do, my technique, nothing special. Lee says you need a minimum of 25 pounds on the handle. So I don't really know what 25 pounds is, but I just come down and I give it a good press, and then I bring it out, rotate it a quarter, and give it another one, and then we call it good. Now you probably can't see anything, to notice, but you can see from the groups that it makes a difference. Okay, now for the accuracy bonus round. So we'll spend a little time on bumping the neck back, or I don't know what you want to call it, setting the headspace back, minimizing your resizing to get a better round. So we're going to use this tool. It's called a comparator. Hornady makes this, and I'm using bushing B350. Oops, can't see it. So B350, and it's a headspace comparator. Now what this tool does, if you're not familiar with it, some of you probably are, but what it does is it allows you to actually measure where the headspace is, or where the shoulder is. So we set it up, we just kind of bring it up here, and I've got it zeroed for here. If you're using a digital, it's a little easier. You just bring it up and close it, and then you get a relevant number. Now in this case, the number you get is not so important as it is to what you're comparing it to. So it doesn't really matter what this gauge says or what I'm reading here. What matters is that I get a reference point, and then I do the same thing every time, and I use that reference point to measure to my new point, which is how much I'm going to full length size my die and push my shoulder back. So in this case, this is a Fireform piece of brass, and it's coming in, just for reference, at 3 inches, 75 thousandths. And that's just the way I have it set up. It doesn't really matter. If I zeroed it, it would be less than that. But the 75 thousandths is the important part in terms of knowing where we're going. Now here's one that's been sized. Now in this case, I've got my die set to push the shoulder back to 70 thousandths. So I've pushed the shoulder back 5 thousandths from what it was fired. Now the way we do that is we take our die, we back it off from the factory settings, which is just sort of an arbitrary that gives me, that the manufacturer knows that if I use that setting where I go down and touch the die, tighten it up another turn and a half, I'm going to always get the case far enough in to make sure it shoots at SAMI spec in any properly chambered firearm. But in this case, because we're reloaders, we can actually establish something that's a little more purposeful for us in our individual firearm. So what we're going to do is we're going to adjust this die. We're going to back it off. We're going to put our case in there, and we're going to start sizing it. And we're going to start adjusting this die until we can measure and see that we're moving off of that 75 thousandths, and we start coming down to, towards 70 thousandths. Now that's my number, is 5 thousandths of a shoulder setback. Somebody else may come along and say their number is 3,000. I want to make sure that I don't oversize the case, push it down to 65 thousandths, but I want to make sure, because that's unnecessary. And remember, this brass is going to be a better fit the least I remove it from the Fireform state that it was in. But in the case of the AR, I want to make sure that I still have enough room to get into battery without causing a stoppage. So hopefully I'm saying that in a way that makes sense. Okay, so something I want to make clear, since we're talking about making custom ammo and setting the shoulder back, if you have multiple firearms like I do, chambered in the same cartridge, you need to make sure you use the one that'll work in both. So in this case, we're going to look at our fireform brass from each chamber, and we're going to pick the one that has the shortest head space. So here's one, in this simulation, 3 inches, 75 thousandths. This one's about 3 inches, 71 thousandths. So I'm going to set my shoulder back for this chamber, or this head space. And then the other one will be fine in it. It'll be a little longer than you need, or a little shorter than you need it to be, and it won't probably have as much accuracy potential as this one. But if you don't want to keep separate piles of brass or loaded brass marked for each chamber, then you're just going to have to do the best you can and pick the one that's closest. So the last thing I'll say is, before you get too far ahead of yourself and make up a bunch that don't work, once you get that shoulder number value established, take some of those cases, load up a dummy round, no powder, no primer, and drop some in a magazine. Make sure that you can cycle it in and out of the chamber just fine without sticking. That way, save you some time and frustration at the range. Okay, guys, that's a wrap for this video. I'm going to finish this up. Hopefully, if you try this, you get good results. Like I said, I can't guarantee anything, but that's always my goal, is to provide you with some new information and further our community. So if you like this video, consider clicking the subscribe button. And I guess now there's a little bell off the side. You need to click that bell if you want to get notifications if I upload another video. I don't make a lot of videos, but I find out that I'm not getting notified if I don't go back to people's channels and actually click on that little bell button. So also, if you like it and you think it's useful, share it and click the like button. Thanks for watching, and be safe.